Good day, I am Edric Ato, ID 121, and I will be teaching CALENG3 quiz number 3. The topic for today will be about horizontal and vertical elements. Let's get right to it. The problem for today will be this. Find the area in the second quadrant bounded by e to the x plus 2, y equals 2, and the y-axis. Show solutions for both vertical element and horizontal element. So the problem would look like this when graphed. Apologies for not using straight lines. So this is the graph of y equals 2. Then this will be the graph of y equals e to the x plus 2. So you can see we have an intersection here at 0, 3. We're going to be using this intersection later. It is also stated that we need to provide solutions for both the vertical element and the horizontal element. Let's first use the vertical element, which is basically the x. We're going to be using the bounds. The upper bound would be e to the x plus 2, and then the lower bound would be y equals 2. The leftmost bound would be negative infinity, and the rightmost bound would be 0. So if we use it, if we get the area, we would be using the integral from negative infinity to 0 of e to the x plus 2 minus 2 dx. We could further simplify this into integral from negative infinity to 0 of e to the x dx. This is simply the limit of e to the x evaluated from a to 0 as a approaches negative infinity. Take note that this is actually an improper integral, so you would be needing limits. I already integrated the integral of e to the x dx, which is just basically e to the x. Now, if we evaluate this would become the limit as a approaches in negative infinity of e raised to 0 minus e raised to a. E raised to 0 is simply 1 minus e raised to negative infinity, which is equal to 0. So it becomes 1 minus 0, and thus the final answer is 1 square unit. Let us now provide the solution for the vertical element, for the horizontal element, or the dy. For dy, our rightmost would be x equals 0, or the y-axis. Our leftmost would be x equals ln quantity y minus 2. Our lower limit would be 2, and our upper limit would be 3. As you can see here, how did we get the leftmost limit? This is because y is equal to e to the x plus 2. If we try to solve for x, we would get y plus 2 equals e to the x. Solving for x, we get x is equal to ln, should be y minus 2. It would get x is equal to ln y minus 2. For the lower bound, since we need the lower limit of y, it is stated here that it is bounded by y equals 2. So our lower limit would be 2. And the upper limit, as you can see here, this is going to be our intersection of 0, 3. So our area would look something like this. Area from 2 to 3 of the rightmost, so it's 0 minus the leftmost, ln y minus 2 dy. This is simply negative of the integral from 2 to 3 of ln y minus 2 dy. Here we are actually forced to use integration by parts, where u is equal to ln y minus 2, so du would be equal to dy over y minus 2, and our dv would be equal to dy, so our v would be equal to y. Our area would now be equal to uv, so it's y ln y minus 2 evaluated from 2 to 3 minus the integral from 2 to 3 of v du. It's y dy over y minus 2. But take note, all of that is still negative because of our negative sign here. In order to solve for the second integral, we're going to have to use long division. If we use long division, we are going to be getting integral from 3 to 2 of say here 1, then y minus 2. We subtract this, so we're going to be getting 2. This would become 1 plus 2 over y minus 2 dy. Continuing this, we're going to get the area equal to negative y ln y minus 2 evaluated from 2 to 3 minus y plus 2 ln y minus 2 evaluated from 2 to 3. Evaluating this expression, we would get a is equal to negative of 3 ln 3 minus 2 minus 2 ln 2 minus 2 minus 3 minus 2 ln 3 minus 2 plus 2 plus 2 ln 2 minus 2. all negated. This would be equal to negative of 3 ln 1 minus 2 ln 0 minus 3 minus 2 ln 1 plus 2 plus 2 ln 0. As you can see here, ln 0 is actually cannot be solved using regular algebra, since ln 0 is actually negative infinity, or the limit as x approaches 0 of ln x is negative infinity. So we actually have an indeterminate term here. But as you can see here, let's first cancel out all the ln 1s, since all the ln 1s are just equal to 0. So we're now left with negative 3 plus 2 plus the limit as x approaches 0 of negative 2 ln x plus 2 ln x. As you can see here, negative 2 ln x and positive 2 ln x just cancel each other out. So this is now equal to 0, which we could just say is negative of negative 3 plus 2 plus limit as x approaches 0 of 0, which is simply just negative 3 plus 2 plus 0. Simplifying even further, we get negative of negative 1, which is equal to 1 square unit, and that is our final answer. I hope you were able to learn something from this video, and thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. Once again, this is Edric Ato from Syntax, paving your way to excellence.